Number one, in this video I'm going to talk about graphing the tangent function. Now you may recall from an earlier video that we were discussing the trigonometric functions of quadrantal angles, that tangent of pi over 2 is undefined. Alright, and tangent of 3 pi over 2 is undefined. That's because tangent theta is y over x, it's equal to sine of theta over cosine theta. And at pi over 2 you get that 1 over 0, which makes it undefined. You get negative 1 over 0, which is undefined. Okay? And it takes on 0 at 0 and pi, as I put in this little table here. And this is what the graph looks like. It looks like a bunch of snakes. Okay? This looks like a bunch of snakes, but there's vertical asymptotes at every k pi over 2, where k is an odd integer. So at plus or minus pi over 2, at plus or minus 3 pi over 2, at plus or minus 5 pi over 2, etc. That's what y cotangent of x looks like. It has a period of pi. Alright? So one cycle right there. That period is pi. That period is pi. And so this is 2 periods of y cotangent of x, shown right here in this graph. That's 2 periods. And we're going to use the vertical asymptotes as a guide when we make other graphs. Okay? So, I'm going to get started. I'm going to put down an example. Y equal to 3 tangent of 2x. And we will sketch 2 periods of this graph. Okay? And one other note. Notice because I have a 3 in front, I want to discuss this. The coefficient of tangent of x is a 1. And what happens is, 1/4 of the way between the vertical asymptotes, it'll take on a negative 1. 3/4 of the way between the vertical asymptotes, it'll take on the value 1. So what you're going to notice when we sketch this graph, alright, if you really want to make it pretty, 1/4 of the way between the vertical asymptotes, the y value will be negative 3, and 3/4 of the way between the vertical asymptotes will be a positive 3. You'll see what I'm talking about. Alright, well the first thing you want to find is the vertical asymptotes. And we start with this 2x. Okay? So we're going to set 2x equal to all these original vertical asymptotes to y cotangent of x. This is our model. So I'm going to let 2x equal that negative pi over 2. I'm going to solve for x. I'm going to let 2x equal pi over 2. We'll solve for x. And I'm going to let 2x equal to 3 pi over 2. And we'll solve for x. In each one of these. Okay? I'll just put a little line here, line here. And once we solve for x, we're going to find our new vertical asymptotes. Alright, so all I have to do is divide it 2 on both sides. And I divide it 2, when I get x equal to negative pi over 4. There's a vertical asymptote at x equal to negative pi over 4. Divided 2 on both sides, I get x equal to pi over 4. There will be a vertical asymptote at x equal to pi over 4. Lastly, when I divide 2 on both sides there, I get x equal to 3 pi over 4. And there'll be another vertical asymptote there. So we're going to start by sketching the vertical asymptotes. Okay, so I'll just make it. Right, y-axis, x-axis. Alright, we need a vertical asymptote at negative pi over 4. Alright. Another one at pi over 4. I'm going to put a tick mark between pi over 4 and this 3 pi over 4. Because what happens, everyone, this graph, the graph of this function, will cross through the x-axis halfway between the vertical asymptotes. So now I'm just going to make a snake. Whoop, whoop. It's going to go. Whoop. Just a rough sketch. And you go, why do I need that value? Well, what's halfway between a pi over 4 and a 3 pi over 4? 2 pi over 4, which is pi over 2. Alright? And this, of course, is the origin right there. Now, let me talk about, that's the graph. Very nice graph, but we'll talk about this 3 here. What I was saying earlier is that 1/4 of the way between these vertical asymptotes, the y value will be negative 3. And 3/4 of the way between these vertical asymptotes, it'll be 3. So what I'm saying is, right about there, boop, right about here, boop. This is negative 3, this is 3. That's what's going on. You can do that to pretty up your graph. Okay? And so this right here, about 3, and right there would be about negative 3. Alright, here's our next graph. Let's sketch y equal to negative 3 tangent of 2x. Well, all this is going to do is take the original 3 tangent to 2x and reflect it about the x-axis. So this is just going to go like this. Alright, this one right here is just going to go like that. So all I have to do is just take this off like this. It'll have the same x-intercept. It'll have the same vertical asymptotes. But this time, what this graph will do is snake this one. Alright, remember? Whoop! So it's going to come down here and just... Alright, there we go. There we go. That's y equal to negative 3 tan of 2x. That's 2 periods of y equal to negative 3 tan of 2x. Same vertical asymptotes. Let's do one more. Let's sketch y equal to tangent x minus pi over 2. Alright. Y equals tangent of x minus pi over 2. Now if you recall transformation of functions, this graph is just going to transform or shift horizontally. Okay? Well, the first thing, let's find those vertical asymptotes. So we'll take this x minus pi over 2. We'll set it equal to negative pi over 2. Yeah, where were the vertical asymptotes of this original y equal to tangent of x? I'll set x minus pi over 2 equal to pi over 2. And I'll set x minus pi over 2 equal to 3 pi over 2. Okay? And then I'll solve for x. So it's important to know this model. Alright? It's important to know this so you can sketch all tangent functions. To solve this and find the vertical asymptote, I have to add a pi over 2 on both sides. And everyone, negative pi over 2 plus a pi over 2 is 0. So there's a vertical asymptote at x equal to 0. Add pi over 2 on both sides. Pi over 2 plus pi over 2, that's 2 pi over 2, which is pi. So there's a vertical asymptote at pi. And lastly, everyone, 3 pi over 2, add pi over 2 on both sides. 3 pi over 2 plus pi over 2 is 4 pi over 2, which is 2 pi. So there will be a vertical asymptote at x equal to 0, at x equal to pi, and x equal to 2 pi. Let's make a sketch. Alright, there we go. Well, since the first one's at x equal to 0, I'll just put that there. Alright, there's going to be one here. I'll put another one at pi. And another one at 2 pi. Notice I put a tick mark between these. That way I know where to cross the x-axis. Because remember, it crosses halfway between these vertical asymptotes. It crosses the x-axis. So I'm going to put a vertical asymptote at 0. I'll put one at pi. And I'll put another vertical asymptote at 2 pi. I'll just build my snakes. Whoop, whoop. Here we go. Come up here, right through there. Come up here. So we're graphing 2 periods of this function. And what is that? What's halfway between 0 and pi? Half a pi. Right? 1 pi over 2. That's 2 pi over 2. That means this will be 3 pi over 2. Halfway between a pi and a 2 pi. And one last thing. Let's talk about this. If you really want to pretty this up, that's a 1 right there. And so what we're saying is 1/4 of the way between these vertical asymptotes, it'll take on the y value, -1. So about between here and here, around that it's taking on -1. And 3/4 of the way it's taking on the value 1. Alright, same thing over here. Okay. So make sure you know that. That's it.